Hey guys, welcome to another virtual classroom edition of Mr. Matthews' class. Today we are going to be talking about intercepts. And before we get started, let me go ahead and apologize in case any of my sound editing doesn't get out. Some of the construction going on near my house. The neighbor's putting in a fence, so if you hear bangs and loud noises, well, sorry, but we gotta do what we gotta do. So today we're talking about intercepts. And the first thing I'd like to show you is a movie clip where a scientist is calculating, well, you'll see, and I'll explain in a minute.
I know why we have satellite disruption.
All right, go ahead.
Okay, let's say.
Quick explanation. This is a clip from Independence Day, a 90s film that I loved, and everyone else did too. I mean, it doesn't age well, but it was fun to watch. And this is a clip where the aliens have already come down to Earth. They're in these big ships. They're all over the planet, or major cities. But no one knows really what they're doing. They haven't said hello. Nothing bad has happened yet. So everyone's kind of in limbo. And this scientist thinks he has used math, mind you, to figure out what's going on.
That you want to coordinate with spaceships on different sides of the Earth. You couldn't send a direct signal, right?
You're talking about line of sight.
Yeah, that's right, exactly. The curve of the Earth prevents it. You'd need satellites to relay that signal in order to reach each ship. Well, I found a signal hidden inside our own satellite system.
Excuse me, Mr. Preston. They're starting.
They're using our own satellites against us.
Now, this is where they reveal his countdown timer. So basically, Jeff Goldblum's character has done the math and calculated when time will equal 0. And he's calculated an intercept, essentially. And he's using this to save the day. Yay, math. Let's watch. Just a couple more seconds.
The clock is ticking.
And this is when the president has to decide, okay, we're evacuating, we haven't done anything yet, but now we've got to get out. Good times. So, intercepts. Okay, so there are a lot easier to understand if you just see a picture. So let's look at this graph real quick. If I were to, I don't know, draw a line, let's make it purple. Okay. And I were to draw this line, it went from, I don't know, from there to there. Sure. There's a line. There's our function, okay? Now, this function has two intercepts, okay? And they are here and here. And maybe this is just the best way to show you. Let's make a red dot. Okay, so if you'll notice right here, fill it in. So let's try that again. I'm going to fill it in. It didn't do it. There it is. Okay. So this spot right here that I've just made a dot on right here, this is called the y-intercept. The reason they call it the y-intercept is because that is where the function crosses the y-axis. That's this guy. Now, you might be able to guess what this dot is. Yep. This spot right here, which I'm so expertly drawing, is called the x-intercept. That's where the function crosses the x-axis. Now, I don't know exactly where these 2 points are at the moment, but I do know a couple things about them. For instance, the y-intercept is going to have an x value of 0. Okay, well, we'll figure out how to get y later, but right now, all I know is that the x value for that coordinate is 0, because it doesn't go over at all, it just goes straight up. And the x-intercept has the inverse. It's going to have an x value, and then its y value is always going to be 0. So that is something to understand. So basically, intercepts are where the line, our function, crosses the y-axis and the x-axis. Now, you can calculate these with some math we're going to do later, or you can just look at a graph and kind of pick them out. So I'm going to do a few problems now that you are expected to do in your lessons, and those are the two skills. You need to be able to find the intercepts based on the way a graph looks. You also need to be able to calculate your intercepts by doing some inverse operations and some substitution. But we'll get to that in a minute. Okay? So that's what we're doing. We are calculating intercepts today. Okay, so here's our first problem, and it says here to determine the intercepts of the line. Okay, so that is sort of my question. No, that's not what I wanted. I want a line. Determine the intercepts of the line. Okay, remember, my job is to underline the question, and that's not really a question, but it is our directions for this problem. So I've underlined the question, determine the intercepts for the line. Okay, now all I'm given is a picture. That's it. That's all I've got to go on. So I know my intercepts are here. Let's fill that thing in. Let's try that again. Here, and it looks like right there. Now, based on this lesson, just going from visual, I'm looking at this scale. This is going up by 10, 20, 10, 20, negative 10, negative 20. But there are these lines between. So that must mean these in-between lines are worth 5. So I'm going to say that this guy right here, make that easier to see. This guy and this guy, these are my two intercepts. This one is my x-intercept because it's on the x-axis, and this one is my y-intercept because it's on the y-axis. So all I have to do is kind of pinpoint their values. Okay, so this x-axis one, this one looks like it is at negative 10, and then it goes 0 up and down. Remember I said that x-axis, x-intercepts would have a 0 value in the y slot, and this one looks like it goes 0 over, but it goes down, and that's negative 45. Okay, so those are their coordinates. So in your answer, what you type in, okay, so the y-intercept, okay, careful now. The y-intercept is when an x value is 0, so it'd be 0, and then you put in a negative 45. Okay, now our x-intercept is on the x-axis. That's when y is equal to 0. And then you looking at the graph, it looks like I'm at negative 10. So, what have I done for this problem? I kind of made sense of the problem by talking about it, sure. Reason abstractly means I'm using sort of like an always true rule, and I guess reasoning abstractly in this one means that I know that from where these are, they always have zeros in certain places, but not so much on this problem. Um, I've been explaining myself and making a good argument for my right answers. I've drawn my models. I'm labeling everything. Using the graph as my appropriate tool. Attaining precision, I haven't really done any calculations here. I guess me counting very carefully is being precise. Let's see, making use of the structure. Okay, so in this case, that would be the scale of the graph. When I said like each line must be 5, that's making use of the structure of the graph. I guess on the next problem, I'll be using repeated reasoning because I know how this one works, so I bet it'll help me on the next problem. Okay, so let's try the next problem. Okay, so here we are in our next problem, and the first thing I want to do is read the question. Well, it says here to determine the intercepts of the line. Okay, this is very similar to our last problem. It's not exactly the same. So I've not that. I've underlined my question basically. So yeah, okay. So since I just did this, the first thing that comes to mind is that I am going to be using some repeated reasoning here, number 8. So what worked on the last problem will probably work on this one. So it looks like I've got an intercept here, and I've got an intercept here. Okay, okay. So this guy is on the y-axis, and this guy is on the x-axis. Okay, so that means now we know where some zeros are going to go. So this one has a 0 in the x column because it didn't go over left or right at all. And this one is going to have a 0 in the y slot because it didn't go up or down at all. So let's see. So this one looks like it's at negative 250. And this one looks like it is up 100. So those are pretty much my answers. I've observed the graph, made sense of the problem. I'm constructing my argument because I'm explaining it as I go. I'm modeling because I'm showing all my work. I'm using the graph itself as an appropriate tool. Making use of the structure, I'm looking at the graph. Unfortunately, these were not in between. These are exactly on coordinates. But again, the big one here is the repeated reasoning. Because I used these skills in the last problem, this one should be easier. So my x-intercept, ooh, they tricked me. The x is on top of the sign. So the x-intercept, this is where I'd say negative 250. R2 is so hard to draw. Negative 250 and a 0. And then the y-intercept would be at 0, 100. Okay. Well, there you go. So when you're trying to find the intercepts by looking at a graph, all you have to do is find where those lines are crossing the y-axis and the x-axis, and making sure you put the numbers in the correct slots because they will try to trick you on that. Okay. So let's move on to calculating intercepts. And they give you different kinds of information. Okay, so now we don't have a graph. All we have is this algebra, this function, this equation. But remembering what we did in the last one, I think you're gonna like this. So what do we know? And again, this is gonna be our repeated reasoning. Let me get my pencil out. Make it easy to see. Okay, right here. So our repeated reasoning, number 8 down here. So if you remember on our last couple problems, x-intercepts always have a 0 for y. And y-intercepts always have a 0 for x. There's my structure as well because I know how coordinates work. Now, knowing that, we can do something called substitution, and we're going to plug in zeros. That was horrible. Back that up. We're going to substitute in zeros right here and here as needed. Okay? And that's how we're going to figure out our intercepts. So, pretty simply, here's my work. Okay? So, let's say I want to find the x-intercept. Or y is equal to 0. So here's what we do. We write down our equation. Yeah? Okay, so 5x minus 9 equals negative 8 y minus 3. Okay. So now we're going to substitute in the 0 wherever the y was. So 5x minus 9 equals negative 8 times 0 minus 3. So now we're going to go ahead and do that multiplication. So that means that 5x minus 9 equals 0 minus 3. But because I am so lazy, I'm not even going to bother writing that 0. Is equal to negative 3. So this is where we do some inverse operations, okay? So now, get a different color. That looks good. Okay, so now I'm going to, what's the opposite of subtracting 9? I'm going to add 9 to both sides. Okie dokie. So what we end up with is 5x plus 0, but you know what? I'm so lazy, I'm not even going to write that. Negative 9 plus 9 is equal to 0. And then negative 3 plus 9 is equal to positive 6. Okay, so a little math practice standard stuff in there. Okay, so reason abstractly, number 2. We get a different color to highlight that. Okay, so number 2, reason abstractly. So here's what I just used. So I know that anything subtracting itself is equal to 0. Another way to say that is that anything plus its opposite is equal to 0. That's the abstract reasoning we just used right here. Negative 9 plus 9 is 0, and that's what we wanted. We wanted to get rid of that so that 5x would be by its lonesome. Okay, so now the next thing we are going to do is we are going to divide both sides by 5. And this is another abstract rule. So another abstract rule is that anything divided by itself is equal to 1. So basically, 5 divided by 5 is going to be equal to 1. Therefore, what we end up with is 1x on this side. But you know what? I'm so lazy, I'm not even going to bother writing the 1. It's just x equals 5, 6. Now, this is where some of your brains are going to melt because you think that all answers have to be positive whole numbers. Well, not today, friends. So this friend of ours, when y is equal to 0, x equals 5, 6. Yeah, so that's a rational value. It can be on a graph. Deal with it. That is our x value. Now, that's when we're finding the x-intercept. Let's go ahead and find the y-intercept. Shall we do it in a different color? Sure. Let's go ahead and find the y-intercept. That's when x equals 0. So we write up the equation just like we did before. 5x minus 9 equals negative 8 y minus 3. Only this time, we're going to put a 0 in where the x would have gone. So that'd be 5 times 0 minus 9 equals negative 8 y minus 3. 5 times 0 is nothing, and I'm so lazy, I'm not even going to write it. So that means that negative 9 equals negative 8 minus 3. Oh, negative 8 y minus 3. That was close. Okay, so now we've got some inverse operations to do. Okay, so this time I'm going to go ahead and I'm going to add 3 to both sides. For the exact same reason I added 9 on the last problem. So this is going to give us... So negative 9 plus 3 is negative 6. And that'd be negative 8y. But since negative 3 plus 3 is 0, that's all I get. Now, the next step. We've got to do some more inverse operations. I have to divide both sides. Oh, yeah, that works. Divide both sides by negative 8. For the same abstract reasons I did in the last problem. I want to divide by the coefficient. That's whatever the letter is stuck to get rid of it. Because once you divide by the same thing, you get 1. And 1 times anything is just itself. So what is that going to leave us with? Let's go to text, bright color. Okay. So that means we're going to have, okay, I'm going to talk about this in a minute. Well, negative 6 over negative 8 is sort of our answer. Equals, now negative 8 divided by negative 8 is 1. But I'm so lazy, I'm not even bothered writing it. So let's talk about simplifying this. Okay, so these can both be divided by a negative 2. So that would be, if I want to write that down, yeah, let's write that down. So this is basically, this is negative 6 over negative 8. Okay, they can both be divided by a negative 2. We're all loving negative numbers. We all love that. Okay, so that means that our new answer, the simplified version, would be negative 6 divided by negative 2 is just 3. Negative 8 divided by negative 2. Oh, I didn't even write negative on that. But that would be 4. So let me back up a second. Grab my... Oh, I didn't black. Okay, so that should have been a negative 2 down there. Okay, so this, friends, is what y would be when x is equal to 0. And I know, you love for answers to be positive whole numbers. Well, not today, which is fine. It's totally fine. So our answer is going to be 3/4. Sometimes they will be whole numbers, just not this time. So in this case, our x-intercept is at 5, 6, 0. And our y-intercept is at 0, 3/4. That's where that line crosses both axes. Okay, we have time for one more problem. So here it comes. Okay, last problem. Here it is. So the first thing I want to do is make sure I'm reading the direction that says determine. That is not even close to being readable. Let's try this. Determine the intercepts of the line. Okay, so that's underlining the question. Oh my goodness. You know what? Let's use the tools they give me, right? Okay, so there's a line. Okay, so I'm going to determine the intercepts of the line. I have gone ahead and I've underlined the question, or in this case, underlined the directions of what I'm supposed to be doing. Now, I am going to be using some repeated reasoning here. That's number 8. Because what worked on the last problem. Now, again, I know that x-intercepts have a y value of 0, and y-intercepts have an x value of 0. So that is like launching me into this problem. If you just remember that x-intercepts have a y value of 0, and that y-intercepts have an x value of 0, everything should be good. Okay, so let's see. I'm definitely going to be, grab my line tool again. I'm going to be solving with accuracy now. That means I'm going to be attending to precision, being very careful with all my numbers. I'm going to make use of structure because I'm going to be writing out the equations here in a second. I'm going to be doing, all my conversation is making an argument for why my math works. So yeah, we'll get to reasoning abstractly here in a minute. Excuse me. People are not robots. Okay, so here we go. Let's go ahead and do our x-intercept first. That's when y equals 0. So our equation is y equals negative 9x minus 14. Okay, well, if y is equal to 0 equals negative 9x minus, that's a negative 9x minus 14. Okay, well, if y is equal to 0, then our equation becomes this little number. All I've done is substitute. I put the y in for the y, the 0 in for the y. All I've done is substitute. So now I'm going to do some inverse operations. I'm going to add 14 to both sides. And the reason I'm doing that, again, is number 2. Abstract reasoning. Anything, any number, when you add it to its opposite, you get a goose egg. You get 0. That's why we did that. So now what do we have? Let's talk. Okay, so 0, that'd be 14, equals negative 9x minus 0. But you know what? I'm too lazy. I'm not even bothered writing that. So I just got 14 equals negative 9x. So now, what I've got to do is some inverse operations where I'm going to divide by negative 9. And the reason I'm doing this is another abstract reasoning point that I'll make in just a minute. So, anything divided by itself is equal to 1. And that is really convenient here because here's what happens. So sure, I have this weird 14 over negative 9 fraction. But negative 9 divided by negative 9 is 1. And I'm so lazy, I'm just going to say that. So, again, as much as you might want whole number integers for your answers, not today, friends. So, our x value would be 14 over a negative 9. And just to be clear, this could also be written as negative 14 ninths in this fashion, or you could even say negative 14 over 9. The negative symbol just has to be somewhere. So when you go to enter your answer, I think it'll take it any way possible, but this is probably the first way you come to it. So yeah, negative 14 ninths is where the line crosses the x-axis. Well, again with the yawning. Oh, why only when I'm on video? Okay, so now to the y-intercept, I'm going to be using more repeated reasoning because this structure works, again, model in my mathematics. Okay, let's change it up, do a different color. Sure, this looks fine. Okay, so a y-intercept, that's when x equals 0. So we write the equation in, y equals negative 9, x minus 14. Then we're going to substitute in the 0 for where the x is this time. So y equals negative 9 times 0 minus 14. Now, once we multiply, I guess, watch what happens. Y equals 0. I'm not even about writing it. I'm too lazy. Y equals negative 14. And if I'm not mistaken, we are done with that side of the problem. Yep. Pretty sure 0 times anything. A little abstract math there. I mean, I'm hoping we all knew that one, but anything times 0 is just equal to 0. So, yeah, y is just equal to 14, I believe. Or negative 14, rather. So your wish came true. It's a whole number. I mean, it's an integer. No fraction involved. So y is equal to negative 14. And that concludes our demo today of how to find intercepts on graphs and how to calculate intercepts from function equations. Make sure to contact me if you need more help. Send me screenshots, questions, whatever. If you're having a problem with your technology, call me. I'm hoping everyone's healthy, hoping everyone's well. And this has been another edition of the Virtual Classroom for Mr. Matthews.